Okay, today we're going to go ahead and go over our chapter reviews. Get your reviews out, and feel free to pause the movie if you ever need to write something down. Let's get started. We're supposed to find the prime factorization of each. You can break this down by using a tree if you like. 175 can break down to 25 and 7. And then 25 can be broken down to 5 and 5. And so 175 can then be 5 times 5 times 7. Next, negative 160. Negative 160 can be broken down. Remember, if we have a negative number to break that down, first thing we do is we change that to a negative 1 times 160. Then 160 can be broken down to 16 times 10. 16 can be 4 times 4. And then 2 times 2. 10 can be 2 times 5. And so 160 will be a negative 1 times 2 times 2 times 2 times 2 times 2. So there are 5 of them. So times 2, 5 times, and then times 5. And the last one, 33a to the third b squared. Remember, when you have a variable in there, first thing you do is separate the numbers from the variables. And then 33 can be broken down to 3 times 11. And then a to the third b squared can be broken down to a to the third and b squared. A to the third will be a times a times a. B squared then would be b times b. And so you'd get 3 times 11 times a 3 times b 2 times. Next, find the greatest common factor of each monomial. Remember here, if we break these down into their prime factors, then we can find the prime factors that they have in common, multiply those together, and that'll give us our greatest common factor. So if we start off with 12 and 90, 12 can be 4 times 3, and then 2 times 2. 90 can be broken down to 3 times 30, and then 5 times 6, and then 2 times 3. Now I look for everything that they have in common. They have a 2 in common. And then they have another 2, or I'm sorry, they don't have another 2 in common, they have a 3 in common. And so the greatest common factor will be 6. Next, I got 20xy and 48xy squared. Break apart 20 and xy. 20 can be 4 times 5, and then 2 times 2, and x and y. Here I have 48x y squared. 48 could be 6 times 8. 2 times 3, and 8 can be 2 times 2 times 2. And I've got x and y squared can be broken down to y times y. And I look for everything they have in common. I've got a 2 in common. I have another 2 in common. I have an x and one y. So my greatest common factor then will be 4xy. On the last one, 39st to the third and 13rs to the third. Okay. 39 st to the third can be broken down to 39 st to the third. 39 is 3 times 13 s t to the third, and t to the third will be t times t times t. 13 is already prime. Then I've got an r, and I've got an s. And if I see everything they have in common, I've got a 13 in common, and I've got an s in common. And that is it. So that's going to be 13s will be my greatest common factor. On the next section, you're asked to factor the polynomial completely. And the first rule of factoring polynomial is you look for a greatest common factor between all the terms. So if we do that on the first one, between 48a squared and 12ab, you should notice we have a 12a in common between both of them. And so if I factor out a 12a, 48 divided by 12 gives me 4. A squared divided by a gives me a, minus 12 divided by 12 is 1. A divided by a is 1. And so all I'm going to have left in this term right here after I get rid of those is I'm going to have a b. And so 12a times 4a minus b will be my answer. On the next one, again, I need to factor out a greatest common factor. If I look at all three terms, you should notice that I have no variables in common between all three of them. In fact, the only thing that you have in common between all three of them is going to be 3. So if you factor a 3 out of all of them, 6 divided by 3 is 2. And then x squared minus 21 divided by 3 is 7. Y squared w plus 24 divided by 3 will be 8 xw. And that'll be your answer. It won't factor any further. On the next one, if you look at all four terms, you'll notice that there are no common factors between all four of them, so you can't factor out a common factor. But when you have 4 of them, there's another technique to factoring, and that's factoring it by grouping. Now if I group them like that, and I factor this first part right here, you'll notice I've got an x in common between those two, so I can factor an x out. And I'll be left with y minus 2z after I factor out the x. Then I have a plus. And if I factor out a common factor in this one, I should have a 5 on the outside, and then y minus 2z on the inside. And then you should recognize at this point then that each one of these has a y minus 2z in common. When I have that, I can take my y minus 2z, put it out in front, and then after I take those out, what I have left is x plus 5. And that goes on the other side, also in parentheses. And so my answer to that would be y minus 2z times x plus 5. In the next section, you're asked to solve equations. And we've been solving equations like this all chapter. And hopefully we're able to do these rather quickly. But if I've got an equation, y plus 4 times 3y minus 5, if I'm multiplying this times this, and I'm getting 0 as my answer, then I know that either y plus 4 is 0, or 3y minus 5 is 0. One of those has to be true in order for this equation to work out. And so after I wrote my two different equations, I solved for y. Here I'll subtract 4 on both sides, and I'll get y is equal to negative 4. And here I add 5 to both sides, and then divide by 3. I'll get y is equal to 5/3. And if I wrote that into a set notation, it'll be negative 4 and 5/3. On the next one, In order to solve this equation, I have to get 0 on one side. So I need to move this negative 11y over to this side of the equation. In order to do that, I have to add 11y to both sides. When I do that, I'm going to be left with y squared plus 11y is equal to 0. After I do this, now I have to factor it. I have to get it into a product of two different terms. So that way I can solve it for 0. So I factor out my greatest common factor, which in this case is going to be y. So if I take a y out of both of them, I'm going to have y plus 11 equals 0. And then just like on this problem over here, I know that either y has to be 0 or y plus 11 has to be 0. And so you should get for an answer there 0 and negative 11. On the last one, you solve it the exact same way as you did once we were right here. I factor out a common factor, which would be an x. If I factor an x out, I'm going to be left with 2 plus x equals 0. And so now either x equals 0 or 2 plus x equals 0. And so my answer to this then will be 0. And then over here, if I subtract 2 on both sides, I'll get x is equal to negative 2. On the next section, this is section 3. And remember on section 3, this is when we're factoring a trinomial where the number in front of a squared, or in this case a squared or x squared, whichever it is, when the number is 1 in front of here, all you have to do is find two numbers that when I multiply them they equal the last number, but when I add them they equal the middle number. So in this case I'm going to get a and a. If this is a plus, that means both of my signs are going to be the same. If this is a minus, that means they're both going to be minus. So I've got a minus times a minus, and two numbers when I multiply them to equal a positive 21, but when I add them to equal a negative 10, will be a negative 3 and a negative 7. On the next one, x squared plus 9x plus 20. Again, it's the same concept. I've got an x times an x. This is a plus, so I know both my signs are the same. This is also a plus, so I know they're both going to be plus. And now two numbers, when I multiply them, they equal a positive 20, but when I add them, they equal a positive 9, will be 4 and 5. And the last one, or the next one. Again, it's going to factor out the product of two sums. And I'm going to have a y here and a y here. This sign is a minus. Whenever that sign's a minus, I know that one of them has to be positive, the other one has to be negative. Next, I need to find two numbers. When I multiply them, they equal a negative 20, but when I add them, they equal a positive 1. Those two numbers will be a positive 5 and a negative 4.